Good morning, everyone. Welcome to the after tea session. Our first talk of the day is by Johan Beyers, who describes himself as somebody who's been doing software for a very long time. And he will be talking to us about Kafka in practice based on his experiences at Takealot. Start when you're ready.
Yes, I'm Johan. I've been doing software for a while. Anything from industrial control, microcontrollers, Python, lots of stuff. Most recently, for the past 5 years, I've been working at Takealot. I am not in charge of managing Kafka at Takealot. I work in a different team, but we are users of Kafka. So, long and short of it is, use Kafka, don't use it too much. In other words, don't use it for things that it's not really well suited to. And the things that it's well suited to is CDC and event sourcing. More about that a little bit later. So, as I mentioned, I am a senior engineer in the marketplace supply chain team. So, marketplace deals with all the sellers that sell on the Takealot platform. We build the tools to let them see their stock, join promotions, see all the financials, all of that. So we deal quite a lot with Kafka in that process. So some numbers. We're 2 teams. We've got 28 code repositories, about 130 Kubernetes deployments, which effectively means that we're running a couple of hundred pods at any one time. On our busiest topic, which is our merchant offer topic, we run at about 13 million messages a week going through Kafka. Now, of those 130 Kubernetes deployments, a good chunk of them, I didn't count, but a good chunk of them are actually Kafka consumers. In our production cluster, this is not in marketplace only, but the whole cluster, we've got about 400 topics running on that Kafka cluster. Oh, sorry, on that Kafka. Right. This I got off the Kafka website. You don't need to read it here. Just look at the highlight, high performance. And the reason you would pick Kafka would be the following few things. High availability. So the thing with a microservices system is that if you have a microservice where the backend database goes down, that part of the service goes down, but the rest of your service stays up. If Kafka goes down, everything dies. It is the backbone of all the cross communication between services. So high availability is absolutely key. High throughput, like I said, one topic, 13 million messages a week. We've got a lot of traffic. I actually asked one of our Kafka team people the exact number. He'll get back to me at some point today. It's scalable. So you can scale horizontally as much as you want. It's really runs at massive scale. And then you've got permanent storage of those messages. The reality is that we have variable retention on these topics. That topic I mentioned with the 13 million messages, I know that's the messages in a week because they get deleted after a week. Right, so how do we use Kafka? We have a few main ways. Now, there are some edge cases, but the main thing is change data capture, event sourcing, and then task queues. So if you cast your mind back to the first slides, I said mostly event sourcing and CDC. I didn't mention task queues there, and there's a good reason for that. Okay, CDC, change data control. So that records raw data level, database level changes, full before and after state on the database. It's all, well, it's from our perspective, it's all automated. There's someone who looks after that. And it runs on all our databases. So the how of that is we use Debezium, which is a connector that can connect into these databases. That pushes it to Kafka, and then Kafka gets all those messages get ingested into BigQuery. So what this allows us to do is we effectively have a data lake. So we can do tracing. We can see stock movements, different things that happened in different databases for auditing purposes. Because if a seller says they didn't do something and we can see that they did, that is useful. Reports, we actually do seller reports for from those from the data that we get there. All kinds of investigations. We have various things that we would like to see. Okay, what's the historical data here? What happened? And we, because it handles all databases, we can trace that all the way through all the microservices. I wouldn't say it's easy, but it's possible. And then historical queries. So we do a lot of data where we want to, say, aggregate the past 30 days sales for a seller. And that we usually get from this, because keeping track of that ourselves means we have to build a whole lot of infrastructure. It's easier to build a good query and get the data from BigQuery. Okay, event sourcing. So event sourcing is a little bit above the database level. We're talking about business objects. So you would have a merchant offer, say, for example. This is now something that the merchant can sell on Takealot. Now, that in the database, you have quite a few tables spread around that comprises that business object. If you just do the CDC part, then you've got a whole bunch of disjointed database changes that you're recording. What you actually want to have is this happened to this business object. So the main idea is we propagate that to downstream services. And then we also, at this level, add in auditing info. So if someone changes the price on one of the merchant offers, we know who did it. That gets included in that data. So the how on this is it's basically in line in the business logic. So we say, okay, we do this change on the database, and then we emit an event. And that is then consumed by other microservices, both internally in our team, and then also other interested domains. When I talk about domains here, I'm talking about parts of the business. So we deal with the sellers. There's another team that deals with Takealot's internal retail department. Another team that deals with finance. So all of those need to be coordinated. So yeah, the main reason is we want to let the downstream systems know that something changed and that they need to kick off their related processes. Okay, now we get to task queues. So task queues are running long running tasks. So usually you would use a queue, something like RabbitMQ or something like that. We use Kafka. This would be mostly tasks that are either kicked off by a user or daily tasks that we run over all our sellers. So the way we do this, we do not rely on Kafka on its own, thankfully. We record the task and the details in a DB. We emit a Kafka event, and then we have a consumer that picks up that specific task from the database and handles the task. For heavier or occasional use, we use Kida. I will go into that in a while. That Kida is Kubernetes event-driven auto-scaling. So that can actually scale on external queues, not only on things like memory or CPU. So that allows us to then scale that according to the Kafka topic lag. In other words, how far are we behind on consuming those messages? That's one of the simpler scalars of Kida. So the why, we needed a mechanism to handle long-running tasks. So in an organization like Takealot, you adopt a technology, and if you decide the month after that you don't want that technology anymore, it takes you about 5 years to get it out. So the Kafka consumers work, and we had a hammer, and it looks like a nail. So that's why we did this. Okay, designing messages. So that's kind of the way that we use Kafka. What I want to talk about now is mostly the event sourcing stuff. Designing your messages to convey the right information to your downstream systems. So this quote by John Gall, I quote this regularly. When you start with a small system, you always start with a small system. Then you build it out and you go microservices and whatever. Then you say, okay, now I need coordination. Then you add Kafka in the mix. Now, at that point, you are not doing an event-driven system from scratch. So there's all kinds of stuff about doing only event-driven systems and then using the events as the source of truth. In practice, you won't see that very often. You will see Kafka being used to coordinate state across services. And it's almost impossible to switch to an event-driven system, a pure event-driven system. So given that, your microservices, your messages will be mostly about data that changed in those services. One strong recommendation is try and keep the shape of those messages the same as the service endpoints, because the people downstream of you are going to hit your endpoints. They're going to see the Kafka messages, and if those look roughly the same, you're good to go. If they don't, you're going to get callbacks. The other thing to keep in mind is all these downstream systems only react to a small subset of changes. So I've got an example here. Again, merchant offers, right? So we have this merchant offer database. We need to be able to show the merchants all their stock and so on. We are not the source of truth for the title of that offer. That offer title gets determined at a higher level. We are not the source of truth for the size and weight of that offer. That gets entered by the merchant. So in theory, yes, we are. Then the moment it gets into the warehouse, there's machinery that actually checks the size and weight. And that gets fed back to us. We are also not in charge of the warehouse stock levels. That is a different team. So all those things, even though we need to be up to date on that information, we have to take that off Kafka streams. So the options of what you can include in these messages, the state change messages, if I can call it that. The simplest thing is just the object type and the ID. Actually, the simplest thing is something changed in my service, but that's not very useful. So the simplest realistic thing is this offer changed. We'll get to how useful that is in a moment. Next up, all the new object values. In other words, you basically take all the database stuff, convert it to something that makes sense in a business object side, and you just dump that into the Kafka queue. Then new values for changed fields. So there you're a little bit more selective. Only these things changed. One up from that, old and new values for all the changed fields. So we'll go through the advantages and disadvantages of all these. And then lastly, the full old and new objects. Right. How am I for time? Good. Right. So the object type and ID, great for cache busting. Not very useful for anything else. Your one advantage that you do have is you have a single code path, and I'll show you that now. If you want to figure out what changed and how I need to react to this, I need to go and refetch the data from the upstream service, which also means that I'm doing a refetch on every message. So I'm doing a lot of work for something that might not be relevant to me. Also, there might be 3 or 4 messages in the queue, interim messages that designated further changes, and when I go and fetch the upstream information, I just get the newest state. So all in all, unless you're using this for cache busting, I wouldn't recommend it. This is kind of what the whole thing looks like from the standpoint of the 2 services coordinating via Kafka. I've simplified it a bit. So you start off with service A producing onto topic A, that gets consumed by a consumer in service B. Now, in this state where we only have object ID and that it changed, I have to go and look, okay, what's my current state? That's a database call. Then I have to go to service A, what's my new state? Get that. So then I determine, okay, something changed. I need to persist the new state on my side and optionally produce another message to a different Kafka queue. So that's kind of the most effort the consumer needs to go to. So how do we make this better? If we have the full new object, that is good if I only want to update state. So I only say, okay, here's the full new thing. I'm just going to take these fields that I know of, and I'm going to upsert that into my database. I don't care if it's relevant. I don't care if the database already has that info. We just do it. Again, you cannot skip based on the message. You have to do it for every message. You cannot also detect transitions between different states without a local DB call, but you can model null fields. So there's a slight subtlety here. A lot of these messages we use JSON formatted message, and a missing key means that this is a field that was nulled, but it's very, very difficult to model if you don't get the full new object. Right, so this is what it looks like. You cut out that upstream call for the new state. Now, new changed fields, that's a bit more lightweight. You can skip based on the content. In other words, you see, okay, this thing changed. I see the title field is not included in the message, and I'm only interested in the title field, so I don't need to do anything. I can skip that message. So that makes the processing quite a bit faster. Again, you can't detect any transitions without a local DB call. What I'm talking about when I'm saying transitions is this thing went below this level. If I get a message, we're interested in this thing needs to be at a level of 10. I get a message, this thing is 9. I have to go and do a local DB call to figure out what the previous level was. So again, DB call that might not have been needed. And on this one, you cannot model null fields. Okay, so same thing, but that whole yellow area you can possibly skip if you see that the information that you're looking for is not of interest to you. Okay, this one is the best bang for the buck. The old and new versions of the changed fields. You can skip based on the content. You can skip based on, oh, this didn't go through a transition. You can model the null fields because the previous value is not null, the new value is null. All of that. Really, really good one. This is the one that I would pick by default. And that's basically what it looks like. If you're lucky, you can skip everything below the produce and the consumer lines. Otherwise, you know what to do. Right, then the last one would be the full old and new objects. That is a little bit heavier, especially if some of these are heavy database calls to make on the producer side. I'm not too, it's not that much heavier for the consumer, but on the producer side, you might, your business object might be quite big, and having to instantiate that whole thing just to put it on a Kafka queue doesn't make that much sense. But it is pretty good for tracking everything. Okay, designing topics. So Kafka has this, okay, who's familiar with Kafka? Who knows what a Kafka topic is? Right, so a Kafka topic is, you say, I want to do a message and I want to have this message that's on a specific channel or queue. Kafka calls that a topic. So the topic gets, it basically works a little bit like a log file. Every message gets appended at the end. And the consumers say, I've seen message number 3,830,000. I'm not going to name the whole number, but and then I want the next one, and then the consumer grabs the next message. So the consumer keeps track of where it is in that stack, and just consumes the newer messages. Now, for the naming, you have 255 characters and a flat namespace. So you cannot call, you've got to be a little bit careful if you want to make full use of that. There are lots of opinions on what pattern you need to follow. As long as you follow a pattern, any one of those should be fine. What makes sense from our perspective is this is the service that sent the message, and this is kind of the business object, say, that we are changing. between the 400 topics that we've got, there's lots more different patterns than this, including ones that are almost impossible to decipher, and ones that include the singular and the plural of the same thing. But yeah, that's a topic for a different for a different time. What helps is naming your consumers well. Ideally, I would like to go onto one of the tools, see this consumer is consuming off that topic, and I immediately have an idea which of our, I think it's north of 570 repositories, I need to go and look at to find that consumer. So at small scale, that might not be that important. At our scale, it definitely is, especially if you're awake at 2 o'clock in the morning trying to debug something. One thing here, including the service name in the name of the topic, is only useful if you are the only service producing to that topic. Not a bad pattern to follow in any case, but yeah. You can have more than one producer to a topic. You can have those producers producing slightly different message schemas, well, very different message schemas if you really want. But in general, what happens then is that you're mixing a whole bunch of things where you have the consumer having to go through everything before they can see any, before they can even determine whether they're interested in that message. Okay, I see I'm kind of running out of time. So we partition. You have to pick the number of partitions when you create the topic, because that can get spread over different machines. A consumer can consume off more than one topic. So if you have one consumer, one consumer, 12 partitions, it'll consume from all those partitions. But the consumer can actually handle multiple partitions. So you can only have, sorry, I'm mixing these things around now. You will never have more than one consumer for a single partition. And you can key your message to partitions. So we typically key that by seller ID, so that all the traffic for a single seller will go to a specific partition, so that we know that those are in order. Because if you have a bunch of consumers off a bunch of partitions, you're not guaranteed that this one will get that dated message before this one that's got a slightly later date. So you might get out of order stuff there. Right, so you have to pick it correctly. Increasing it while keeping the ordering is really, really painful. Don't do it. I like numbers that are divisible by many things. So if you have 12, then you can have 1, 2, 3, 4, 6, or 12 consumers, and they will spread equally across those partitions. 30 is also a nice number because that includes 5, and you've got a bunch of options. Typically, what I would like to do is have the partitions be at least twice the amount of consumers that you want to have on that. Okay, so we default our consumers to handle 500 messages at a time, and on shutdown we only have 30 seconds to do that. This is not a great solution, because if those things take a while to process, you're missing messages. So this is something that you have to tune. These are just the defaults, so you can tune that. Make sure that if you grab a bunch of messages off that topic, that you are able to process them fully before your consumer gets shut down, especially if you're using scalers. Scaling is very blunt. It stops all consumers, rebalances them, the new ones over all the topics, and then restarts. That typically takes about 30 seconds. KEDA. KEDA has two modes that work well. So we've got a scaled object that auto-scales the consumers, which works relatively well for varying traffic. Then we've got scaled job, which is good for the task queues. Long running, very low volume of traffic. Bad things that we've seen, low message volume, especially low message volume mixed in with a high message volume, other type of message. You have a consumer sitting there idling, doing nothing. Then if you have low message volume on a single queue, on a single topic, you want to scale on topic lag. KEDA is good for that. Regular bursts also a problem because that triggers a rescaling of your consumers, which stops everything for about 30 seconds before it starts up again. If we have long processing time, like I mentioned, if the queue cannot be cleared, you need to do a smaller internal queue, so you only pick a few messages and process them, and you make sure that you commit at the right time. You commit your new offset at the right time because you have options for that. You can either commit it immediately or only after you processed. We had a failure mode using KEDA scaling a while ago, where KEDA would scale, sees a spike in volume, adds a bunch of consumers. Unfortunately, the KEDA default timeout to see if something is live is about 30 seconds. So remember, I said when you're scaling, it takes about 30 seconds for those consumers to actually start consuming. And it also takes about 30 seconds before they then say, okay, cool, I'm alive. So KEDA would then shut down those consumers, see that it still has topic lag, and retries that. So basically that's a rebalance storm. We had things going out until we actually, I think we disabled KEDA on that for just a while, and then we had a working burn down of that topic lag. Yeah, many event types. I think I've chatted about that. And I think I'm okay for time. Yeah. That's it.
All right, we have a few minutes for questions. Any questions?
Hi, thanks. I've never really worked with Kafka before, but the last company I worked for had quite a lot of, I'm going to say, similarities between how the messaging was done between the services. It did happen quite often that messages either got stuck. So in situations like that, what would you say is the best way to kind of, one, monitor the flow of the message, and to just make sure that everything is being processed as usual? Is there like a dead letter queue as well? Is there retry policies in place?
Yes, our consumers, our internal, we have libraries that to set up consumers, and those usually have like retry queues that we can pop messages onto if they get stuck while processing. Is that what you mean? Yeah. So we have a retry queue. They get popped on that retry queue, and after a while they get consumed as well. So that consumer would typically then consume from the retry queue as well. Did that answer your question?
Yeah, so just the message goes through to the service and if a message does go through to a service and let's say the service throws an exception that wasn't handled, what then happens to the message?
Yeah, well, we normally so exception handling is like a whole different ball of wax. You have to see where that happens. If it's something that's retryable, then we would do a retry. Otherwise, we'd alert on that. We also alert on topic lag. So if something gets stuck or takes too long, which is a common failure mode, you'll immediately see that in the topic lag. We pick up upstream services being broken by the topic lag.
Hi, great talk. I think you mentioned you used JSON. Is that because of dynamic schemas, or do you use that serialization, deserialization as well?
History. We use it because we've started using it. We actually have a registry for JSON, JSON schema registry, just to keep control of the format of the messages. We're looking at other possible options, but I can tell you it's probably going to be a few years before we use anything other than JSON.
Thanks, Johan. That was really, really interesting. Yeah, I have a question around Kida. I think that's a new concept. I've never heard of it. So if my understanding is correct, that's sort of what you use to sort of scale up and down your consumers.
Yes.
Do you know the complexity of sort of working with Kida is in terms of getting a consumer to be, Kida is the complexity of integrating Kida with a consumer sort of.
So Kida is basically a Kubernetes-based thing. So it's a Kubernetes operator. So what it does is it every 30 seconds or so, the operator you say, look at this topic, get the lag. If it's higher than a certain amount, then spin up more pods. So that's kind of the simplest mode that Kida runs at, is specifically topic lag, because that's kind of a known thing where you want to scale up. And the problem is the consumer doesn't necessarily use more CPU or RAM because it's consuming a lot of messages. So you get things where the consumer gets a lot of topic lag, but you don't see it. So yeah, Kida basically just does that. It's got connectors so that you can actually format a database query. And if that's, so it runs it every 30 seconds or so. If the result from that query comes back in a specific way, then Kida can operate that. So yeah, basically you can probe anything in your system with that. Really, really useful at for that type of thing. So,
Cool.
yeah.
Hi, everybody. Great topic, and thanks for delivering it in that way. It was understandable. So I just want to check, which is the best practice, to have one consumer per topic or to have multiple consumers for one topic?
So the interesting thing about this is that when you produce to a topic, anyone can consume off that topic. So we would have a topic that we initially created for our internal use in our systems. 3 months later, we see another team has been using that because they need that information. So definitely you can have more consumers of one topic. There's all kinds of stuff around consumer groups and so on, which complicates everything. But, that's the basics.
Again, fantastic topic, learning a lot. I only learned about Kafka maybe a couple of weeks ago because a certain friend of mine works at a fruit-based technology company, and he said across their various platforms they use this to communicate things. Maybe a bit of an abstract question. Don't need to answer it now, but I figured lots of Kafka people in the room. Does the concept of missing data exist in a Kafka object, and then how do you handle it?
Yes, so you're talking about at least once, at most once, exactly once delivery, that type of concept. Yes, it depends on the configuration of your consumer. There's certain guarantees that you can make when you commit the new offset just after having grabbed the message, or whether on the other hand you commit it after you've handled the message. So there's all kinds of trade-offs there. Yeah.
We are running a little bit late, so I'm going to cut off conversation here. I'm sure Johan will be happy to gripe about Kafka further.
Absolutely.
But you can thank the speaker again and give us a moment to set up the next talk.
Okay.